important one. Whoops, the recording has just been started. That's good because you'll want to be able to follow along with me later on the video. There are two main types of data I want us to think about today. That is categorical variables and continuous variables. Categorical variables are descriptive labels for different groups in the data. Now, this slide sort of is for a hypothetical situation. If we had a bunch of school children taking data on themselves, the type of thing that might be an introduction to data for school children, categorical variables would be things like eye color, hair color, that they could be grouped into categories on the basis of. Continuous variables are kind of the numbers, if you like, something that has a range of values on a sliding scale. So in that same example, their height and their weight would be continuous variables. Time and date is one we think about a lot and work with a lot in journalism. And it's an interesting one because we can kind of send it either way. So let me just demonstrate that. While it's not environmental, I'm going to use COVID data for examples in a couple of cases through this session because it helps illustrate a bunch of things. So here, what we've got is the worldwide daily reported deaths from COVID through the first couple of years of the pandemic. And here, time and date is basically just moving from left to right on here. It's being treated the same way a continuous variable would be if you put it on to the horizontal or x-axis of a chart. Just as we go along, the time and date is incrementing. But you'll probably notice in that there's a weird pattern up and down, and that's because it's reported and there are bureaucratic delays. Deaths tend not to be reported over the weekend, so there's a weekly pattern. And if we want to see that more clearly, we can treat time and date now as a category, not as a continuum. And there we see here, it's exactly the same data, but I've basically counted all the deaths over the same period according to the weekday they were reported on. So that's just an illustration that you can take time and date. You don't just have to consider it as continually increasing. We can group it into weeks, days of the week, into months, into quarters, and so on. Okay. I may talk a little bit about tidy data. What do I mean by tidy data? And this is a structure for data that if you're doing any analysis in a spreadsheet, is usually going to be where you want your starting point to be. Tidy data means that one variable is in one column. So each separate column in a table of data in a spreadsheet is a separate variable. And one record or one thing that the data is being collected on is one row. If you're in that shape, doing the stuff that I'll show you later, like generating pivot tables in a spreadsheet, will work just fine. But data, when you obtain it, isn't necessarily in that format. And I'll come on to that more in the second session to show you how to fix it if it's not. Okay, this is tidy data, right? This is actually the data I'm going to demonstrate working in a spreadsheet with later in this session. And it's data on the world's countries for various, I guess, demographic, economic, and environmental variables. So we've got things like total CO2, or they're actually total greenhouse gas emissions, in CO2 equivalent, the percent of land that is forest, the percent of land that is arable, and so on. And one record here, one row, is data for one country in 1 year. with year being another variable. And that is a good, tidy data set. Okay. So I like to flag when I'm showing you the kind of any slide that has the sort of central message. This is definitely what you need to sear into your consciousness. And the next one is that. So what are the basic operations for interviewing data? Now, as a pretty much full-time data journalist, I do a lot of things with data. I do statistical modeling, I do machine learning, I do all of that type of stuff. But still, probably 75% of what I do is these basic operations, rinsed and repeated in different orders to give me answers I want. And what are they? Sorting, filtering, summarizing, and joining. Summarizing, I'll talk a little bit about subsequently to this slide because it often goes with another operation as well. Sorting, just ordering, largest to smallest, oldest to newest. Alphabetical order, I guess, a bit less interesting. But often as journalists, we want things in time order, or we want them in the order of magnitude for some particular variable. Filtering. This is selecting a defined subset of the data. I'll show you both of these, or I can show you both of these in the spreadsheet later on. Very simple stuff to do. Rarely is the story you're trying to find in all of the data. It's quite often in a defined subset of the data. So you need to know how to filter. And then summarizing is basically sort of distilling the data down. So deriving one value from a series of other values to produce some sort of summary statistic. And we do this a lot. Those summary statistics might be the sum. If it's numbers, the sum is add them all up. It might be what we think of as the average, or what statisticians will call the mean. It might be the maximum, the minimum, and so on. That's summarizing. Joining, which I won't show you today, but I will show you in the next session, is where you've got data in two tables and you need to bring it together. And you need to bring it together based on matching values for variable or a variable or variables that are present in both data sets. That's a very common thing you need to do as well. So sort, filter, summarize, and join, really key stuff. And a lot of the trick of getting into the way of doing data analysis is figuring out the questions you have and then working out, so how do I need to use these operations to get an answer to my question? Now, I said I'd come more to summarize, and that's because summarize is often done in conjunction with grouping. So often you don't summarize across the whole data set for a particular variable. You group by one variable and then produce a summary for another. Often we group data by categories in the data and then summarize the continuous variables to get averages or medians or stuff like that. I also very frequently group data by periods of time, for example, years or months or weeks, and then calculate a summary for each group. It's a very, very common thing that we do with data. And again, I'm going to show you how to do it with pivot tables in a spreadsheet later on. Okay, if you've got categorical variables, there's not really much summarizing you can do other than count the number of records. So that's fairly straightforward. Continuous variables, the numbers, as it were, many more possibilities. I've already mentioned some of them. We can add all the numbers up. That's a sum. Mean is what we think of generally as the average. That's add all the numbers up and divide them by the number of records. That's what the average or mean is. Median, and I'll show you why you might need to think about medians rather than means, is if you lined all the numbers up, which one is in the middle? And it can be rather different from the mean, which is why you need to think about it, maximum, minimum, and so on. Now, as somebody who thinks about data all the time, I'm always very interested in the distribution for any continuous variables because it will affect primarily how I think about summarizing it. So let me just show you something here. If anybody knows what type of distribution we're looking at, just whack it into the chat. But this is the distribution for basically the difference between the summer daytime temperature. It's all measured from satellite by NASA in the middle of a city to its surrounds. It'll be about 10 or 20 kilometers outside. I can't remember exactly what they did off the top of my head, but that's what they're measuring is that temperature difference. And it's to get at something called the urban heat island effect. It's been done for tens of thousands of cities here across the world from satellite data. And you see that generally cities in the summer are a little bit warmer than their surroundings, and that's because of the different effect of when the sun shines on concrete and such as when it shines on vegetation. You get a warming effect. Okay. This, I don't see anything in the chat, but this is what's called a normal distribution. So it's, I've done little increments to make this chart of about 0.25 degrees, I think it is, along the horizontal or x-axis. And then I've simply counted the number of cities that have that difference in temperature in that range. And I produce a chart. It's called a histogram. Don't need to worry too much about that. But a lot of natural phenomena have this very symmetrical normal distribution. Now, if you see something like that, summarizing by the average is fine. The average and the median are going to be almost the same number. So, but if you're dealing with any socioeconomic data, it's not going to look like that. It'll typically look like this. It'll be a very skewed distribution. This is the distribution of wealth measured by GDP per capita. GDP, total measure of economic activity, here by country. And per capita just means per person. It's a rate. I'm going to talk a little bit more about rates. They're important. So it's a measure of the wealth of nations. And again, I've done it, I think, in increments of $2,500. And I've simply counted the number of countries in each wealth band. And you'll see most countries are down at the bottom end. There's a few way out here. I think that will be Luxembourg, most likely over there. But most countries have relatively low wealth. That's a classic sort of bottom end skewed distribution that, as I say, you will see for a lot of socioeconomic data. Now, why am I drawing this to your attention? Well, if you're going to produce a summary for a typical value, which is what we often want to do, we're sort of not just looking at the maximum, the median, but what's the typical? That's what a statistician would call a measure of central tendency. Do we use the average or mean, or do we use the median? Now, if we use the mean on that data, it'd be somewhere just over 20,000 in this data. But if we use the median, it is rather less. Now, I would argue, and I think many data journalists and many statisticians would argue that if that's what you're looking at, a distribution like that, the median may be a better measure of what is typical if we think of the wealth of a typical country, because the mean gets sort of dragged up by these outliers with very high wealth. Okay, they have a disproportionate influence on the summary. Another reason you might think about the distribution is if you're going to bin the data or put it into buckets. So we're not going to consider every single value, but instead, for the purposes usually of visualization, and I'll we'll have later sessions on visualizing data as well. You might need to put it into bins. So again, that same data. And here, if I'm going to put it into categories, and you'll see why I've done this in a minute, I'm looking at this and I'm saying, well, relatively few have a GDP per capita of more than $40,000. So maybe what I'll do is I'll set the, the bottom end for the top bin for that data at 40,000, and then I'll just have equal intervals below that. Now, if I do that and I make what's called a choropleth map of it, the world's wealth in 2020 looked like that. Now, here's another map, exactly the same data, and all I've done is change the boundaries for the bins. Now, neither of these is right or wrong. It's kind of what you want to show. And in this case, kind of editorially, what I'd be trying to get at by sort of having the bins at the bottom end be smaller is to show the difference in this measure of wealth for the majority of countries that are down at the bottom end, as you saw in the distribution, which might be something you want to bring out from the data. And that's how I've set the bins here. And they've been roughly set to give me roughly equal number. Well, they've been set to give me roughly equal numbers of countries in each bin. So just a couple of reasons. The most important one being how to summarize a typical value of why one of the first things you might want to do with any numbers in your data is look at its distribution. And I'll show you how to do that very simply in Google Sheets later on. Okay, so moving on to some sort of general principles stuff, numbers in the newsroom type stuff, precision and rounding. Often when you are running calculations on data, you'll get numbers with very many decimal places. You don't usually want to be presenting that to your audience. Certainly what you should do is think about the precision with which the numbers were measured in the original data and round the numbers so that you don't give them sort of more precision than that. So you don't mislead your audience by suggesting that these numbers have been much more accurately measured than they have. Okay. Rates. I said I was going to come on to rates and percentages, which are just a special case or just one case, not even special, of rates. Rates are one number, the numerator, divided by a number, the denominator. Multiply a rate by 100, and that's a percentage, percent per 100. Multiply it by 1,000, and you have per 1,000 of whatever is being counted, and so on. Why do we care about rates in journalism? Well, they're usually needed for fair comparisons. And I'm going to illustrate this with some COVID data again, because it's sort of rather convenient. It's not environmental data, I know, but it's rather convenient to illustrate the point. So by the end of 22, so more than 2 years into, well, I guess a bit less than 2 years into, is it more than 2 years into the pandemic? Doesn't really matter. I tallied the number of deaths recorded in Thailand and Malaysia, two roughly neighboring countries, and they were pretty similar, 33,500 or so in Thailand, nearly 37,000 in Malaysia. But the population of those countries is rather different. Thailand has over twice the population that Malaysia does. So if we're considering how severely those countries were hit by the disease, that we need to calculate a rate. We need the number of deaths divided by the population, the numerator divided by, divided by the denominator. Now that gives you some very, very small numbers, which would be ridiculous to present to an audience, right? We are very, very bad people at understanding very small numbers as decimal fractions like this, or indeed any other type of fraction. or very large numbers. I'll come on to that in a second. So when you've got your straightforward rate gives you a very small or a very large number. That's when you need to think about multiplying it or dividing it by something. And here, a reasonable thing will be to record the number of deaths per 100,000 people. And then if you make that calculation, we have a very straightforward, much easier to understand from an audience idea of how severely these countries were hit. Thailand had 48 deaths per 100,000 people, rounded to the nearest death. It makes sense to round it to the nearest death. You can't have a fraction of a death that you're dead or alive by the end of 22. And Malaysia had 114 deaths per 100,000 people. So just an example of why you use rates and why you sometimes talk about per thousand, per 100,000, and so on. Percentages, as I've said, just the same, but the per is 100. We often don't think about that because we're so used to thinking about percentages. Rates can also help us understand very large numbers. Now, I don't know if you have much idea of what $1 trillion is. I don't. Here, somebody's tried to visualize it by stacking dollar bills in piles in a little graphic against the size of objects that we might know the size of, like the White House before Trump demolished the East Wing, a passenger jet or an American football field. Well, that's, we don't really want to be doing that all the time. Let me just talk about another device of using a rate that can help an audience understand a very large number. I've just drawn a chart of the growth of China's GDP in trillions of dollars up to the early 2020s. Pretty impressive, particularly as these numbers are inflation corrected as well. Okay, but what is 27 or so, whatever that number is, trillion? Well, we're very bad at that. But if I make it into a rate, if I consider China's GDP per capita or per person, well, China has a lot of people, we get numbers that we can get our head around. So it's gone from, a very low number down here to, I don't know, what's that, $18,000 or so. $18,000, $20,000. Those are numbers we understand. We understand what they mean. They're sort of in the frame of our general reference. Rates, I really want to warn you about this, and I'm going to show it later. Be very careful when summarizing rates at new levels of grouping. It's often something you need to do. You've got a rate at one level, let's say GDP per capita or per person, for all of the countries in the world, let's say. But you want to recalculate those numbers by region, let's say, sub-Saharan Africa, Asia and Pacific, and so on. Now, if you're doing that, you can't do it straight from the rates for all of the countries. What you want to do instead is take the sum of the GDP for all the countries in each region and divide by the sum of the population for all the countries in the region. Never calculate a sum of rates. It is arithmetically invalid. It'll give you numbers that do not mean anything. And it seems obvious when you think about it, but the number of times I've seen students do that, or you might take an average of the GDP per capita across the region, but it isn't the GDP per capita for the region. It would be the country level average, which is a slightly different thing. And I'm going to show you how to deal with stuff like that when doing pivot tables in a spreadsheet. Percentage change, probably one of the most common statistics we calculate in news, in journalism. always remember the correct formula. It is the new value minus the old value. Do that bit first. That's why it's in percentages, in parentheses rather. Divide it by the old value, and to get a percentage, multiply it by 100. And finally, I think this is the last slide. Don't drown your audience in a sea of statistics. A thing that many people do, many reporters do when they start to work with data is thinking that good data journalism means a lot of numbers. It does not. It is rarely enlightening and usually off-putting to your audience. Use only the numbers that are necessary to get the point across. You may have seen a lot of numbers during your interviewing of data, but that doesn't mean that the audience needs to see all of that. Okay. Oh, and no, there is another slide. Yeah, one more slide. And it is tremendously important. It's probably the second most important one I'm showing you today, which is that you need to check, check, and check again. It is very easy to slip up when working with data. Just do something wrong in a spreadsheet formula, just do use the wrong operation. So you need to develop good habits of running sort of regular reality checks on your data. If you're using a spreadsheet, get into the habit of spot checking individual numbers to confirm that they're calculated correctly. Do it on a calculator or something. And just ask yourself if the numbers you've got actually make sense. Often you can see that a number you've calculated or a whole column of numbers you've calculated are obviously orders of magnitude too large or too small. So you've got to be your own harshest critic in when running any sort of data analysis or interviewing data, checking all the time and assuming that you very well might have made a mistake that you're going to need to correct. Okay, so that's it for my initial presentation. And now I'm going to go on. I mean, if anybody has any questions on that, feel free to, as I said, I've had the chat open, so I'm not seeing anything in there. But if you have any questions you want to shout out about that, you can do it quickly now, or we can wait to the end. Okay, all right. Not hearing a lot of interventions there, so I'm going to go on into the demo of working in spreadsheets and demonstrating some of this stuff. I'm going to use Google Sheets. The reason I do that, it's the same for everybody. It's an online tool. There may be times when you're working on investigation, you don't want to put your data online, in which case you'd want to use a tool like Microsoft Excel or LibreOffice Calc or so on. But I use Google Sheets always for demos. Other spreadsheets may have some slight differences, but the general principles will be the same. So you can use Sheets from Drive in your Google account. As I suggested, watch me now, follow along later. The data that I'm using will be at this link. What downloads will be a zipped folder. You can unzip it, and then you'll find the data. And the file we're going to use today is called indicators. I'll show it to you. And it has that data. Actually, I showed you in the slide earlier. It is data on various economic and environmental variables from the World Bank's World Development Indicators portal, which can be a good source of sort of international comparative data. Okay, and I'm also going to pull some data in from the web as well, but we'll get onto that in a minute. Okay, so let me get into my Google Drive, and then I will want to be in my folder that I've set up for this training. And okay, so what I'm going to do in my Google Drive is create a new spreadsheet to start off with. So that's just going over here, going new, Google Sheets. And that will open up a spreadsheet into which I can now import data. Now, the data, I've already downloaded it. It will take a little time because it's got a hefty load of PDFs that I'll show you in the next session. But there is this thing, indicators.csv. CSV means comma separated values. It's just a text file. It's a very common format with data. I'll talk more about formats for data next time, where each record is, each row is a row. There's a header row at the top, and then all the data rows, and the columns are separated by commas. That's what it means. It's just a text file. Okay, so that's the data I'm going to import. So going back to the spreadsheet I just opened, to import data into Google Sheets, I go to the File menu and hit Import. And that should allow me then to navigate to where my data is. I want to go Upload, and I'm going to browse. And indeed, because I practiced this yesterday, I'm already in the right location on my computer. So I'm going to select that indicators file. It'll import, and then I have some options of what I want to do. I'm going to replace the current sheet. Replace spreadsheet will be the same at this point, but you want to be careful with that one. If you already have data in a spreadsheet, you don't want to write over it. So either create a new sheet and then go replace current sheet, or insert it as a new sheet, another option. But I don't have any data in here, so I'm just going to replace the current sheet. It should recognize that it's comma separated. But I could select that, but it'll recognize it. And I'm going to say, yeah, if you see stuff you think is numbers, dates, and formulas, convert it. Okay, so if I do that, the data should all appear. I'm going to close down that little right menu. And we have all of this data that I showed you in a slide previously. Now, the first thing I always do is to make sure that my header rows telling me what the data is are always in view. This is rather easier to do in Google Sheets than some other spreadsheets. You just go over here to where the numbers are, numbering the rows, and you just drag down that little line. And I usually then bold them up so they're more obvious. So now, wherever I navigate around this spreadsheet, I can see the header rows. So we've got a bunch of stuff in here. I'm only going to work today with population, GDP per capita, CO2 emissions, and so on. But if you want to play around with forest, land area, later on, you can do that to your heart's content. So there's some more data in there. So I said that one thing I would show you is filtering some of these operations. So I'm going to do a filter and a sort to start off with. So also good practice before I do anything, name everything. When you come back to it, you don't want a whole bunch of untitled spreadsheets and tabs in that spreadsheet that you haven't told yourself, the future you, what they are. So I'm going to rename this, and I'm going to call that all years. So I know that that's the data for all the years in the data, which run from 2010 to 23, to 2023 rather. And I'm going to call it nations indicators. so I know what the spreadsheet is. Get into using the habit of naming variables, naming spreadsheets, naming tabs in spreadsheets with simple descriptive names that will tell you what they're all about, because you will forget. At least if your memory is like mine, you will forget. Okay. All right. So I've done that. That's good. What I'm going to do now is filter the data for the most recent year. So I can hover over this column if I want to just do that. I'm going to show it you by clicking in this gray thing between the letters for the columns and the number for the rows, and that selects all the data. And if I go to the data menu, you'll see one of my options is to create a filter. Now I'm going to do that, and you'll see, well, everything's gone a bit green. But what has happened is these little sort of downwards pointing triangles have appeared over every column. If I just highlighted year and gone data create a filter, I would only have one on column D, which is year. Okay. Now, if I click on that, you'll see it's actually a drop-down menu. And if I want to select a year, I can now filter in various ways. So filtering by conditions, I could do things like greater than, greater or less than. You'll see there are date filters. There are various ways to filter text. This is pretty simple. I just want to select one year. So what I can do is not use the filter by condition. First, I need to clear. So I've removed all of those check marks, so nothing is selected. And now if I type in 2023 and select that, I should, when I hit OK, have only the data for 23 selected. So I'm filtering for 2023 alone. Okay, boom, I've done it. And so I have that. Now, the thing to bear in mind, if you then want to go off and do stuff with this data, is you need to copy it and put it in another tab of your spreadsheet. The reason is this data isn't the data other than year 2023 is still in this sheet. What we've created is a filtered view. It hasn't removed any data at all. So what I want to do, if I want to go on and then look at, say, the distribution of GDP per capita, which is the next thing I'm going to do, I want to copy all of that data. So I'm going to select it all. Again, I can do that by clicking here. Then I'm going to go on my machine, Control C, Command C if you're on a Mac, and then make a new tab, a new sheet. Do that with this little plus sign here. So now I've got a nice new sheet, and now I can paste it in with a Control or Command V, and you'll see there it is. Now we've got something else to name. Let's rename that and call it 2023. So we know for that one, it's just the data for 2023. Again, I'm going to drag that down so my header row is always in view. Okay, so that's how you kind of create a filtered data set in a spreadsheet, and you can filter on more than one variable, right? To create whatever filter you want. So I'm going to select this column GDP per capita because we've already seen that that's a pretty skewed distribution. And I'm going to show you very quickly in Google Sheets how if you want to look at the distribution for a continuous variable, which is I've recommended is something you should be doing, you can just quickly insert a chart and take a look at it and make one of those histogram charts that I showed you. Okay, so you can either just use that icon if it's in view. It might not be, however, if your screen's rather small. So the totally reliable way of doing it is insert chart, and you'll see the same icon. And when I do that, actually by default, it's going to create you a histogram. It has the increments it's used because it's selecting the number of columns to create rather than thinking about the values that that will give you are rather weird. So we can customize that, go over to the chart editor, which opens up automatically. You can also find it there. In fact, now I'm going to have to find it there because I closed it by accident. And then you can go and customize it. So there are many types of charts that are available to you in Google Sheets. It tries to select the one it thinks you probably want, which was right in this case, which it was a histogram. Okay, so I'm going to go over to customize it. I'm going to go over to histogram, and you'll see my bin or bucket size or increment size is automatically set, but I can put a number in there. So if I go 2,500, it should do it on increments of $2,500. And whoops, what's going on there? 2,500, probably need to hit return. Yeah, I do. And now we've got, okay, this is for the year 23 rather than 2020, which I showed you in the slides, but you'll see it's a very, very similar distribution, as you'd expect, because the world hasn't radically changed in those 3 years. Okay, and let me just demonstrate what I told you about in the slides. I'm just going to calculate the median and the mean GDP per capita across countries. That's a country level average or median. It doesn't mean that's the GDP per capita for the entire world. It's a slightly different thing. But let's just calculate it to see how different those numbers can be with that. Actually, I'll do them the other way around. I'll do mean first and median, because mean is sort of more familiar to people. Now, all formulas for calculations or other sort of operations on dates or editing text in a systematic way, all formulas begin with an equal signs. I'm sure most of you know that already. And then we can use a function. And the function, I'm just get started typing average, and the ones come up. The function to calculate a mean is called average. It's just the common phrase for it. So, and it then opens parentheses. Now, the data you operate on goes in the parentheses. So if I select column G, it automatically fills in G colon G. Colon in a spreadsheet means a range. I could have gone G2 to G, whatever the last row number in that data is, but G colon G just means take the entire spreadsheet, close the parentheses, and there we go, just over $30,000. The function to calculate a median is, not surprisingly, median, and it will be the same select column, that entire column, and you see it's just over 30,000 against just under 20,000. Those numbers are pretty different because we're in a pretty skewed bottom-heavy distribution for the GDP of the per capita of the world's nations. Now, making things a bit easier to read. Firstly, I'm going to format that as currency, some basic format options here, more format options from the format menu. And I'm also going to, the cents, I think, are somewhat distracting here, and I can decrease the number of decimal places easily with those two columns selected. So it's now a bit easier for humans to read than me as the poor reporter who might want to quote this number as a story to formulate it in dollars and to round it to the nearest dollar. Okay. All right. So let's get rid of those two columns, and let's do a quick sort as well. I'm going to get rid of the chart as well, get that out of the way. So let's go to GDP per capita and sort on that. And I want to give you a big caution here of this is a place you can easily go wrong. When sorting on the values for a particular column, you want to make sure to sort to the sheet, not the range. The range will just sort that column and leave it all out of order with everything else. So sort the sheet, not the range. And if I want to go from the richest country in the world in 23 to the poorest, that's Z to A, or Z if you're British, going with British English, which is the English of the country of my birth, but not where I live now. That's what Z to A means for numbers. Okay, and we'll see, as I think I suggested, it's Luxembourg that's up at the top. Okay, and again, I could formulate that so it's a bit easier to read. I think, was it Singapore that was nearer to the top? By the way, what have I done? Yeah, no, it was Luxembourg, but somehow I managed to delete one of those numbers. I'm not quite sure what I did there. If you think you've done something wrong, hit Control or Command Z or Z to go back and fix your mistake. Hopefully you haven't gone too far. All right. Okay. So we've done some sorting, we've done some filtering, we've done a bit of rounding and formatting. Okay. Now, let's go back into all of the data and do some slightly more sophisticated stuff based on kind of where you told me you were comfortable with in the survey we did. So I am going to calculate a new column in this data. I'm going to take a rate and make it into an absolute value. Then I'm going to do some grouping and summarizing. Okay. So first, however, I'm going to take off these filters because I want to look at all the data. So data, remove filter if you don't have one. That's what I did. Okay. All right. So we're going to look at this CO2 emissions. Now, this is it's actually greenhouse emissions in CO2 equivalent, and it is in millions of metric tons. So that's quite a large number. Okay. So I'm going to put in a new column in my data to the right of that. And I'm going to call it CO2 emissions per capita, per cap. Use the same summary, the abbreviation I use for GDP. Okay. All right. So what is the basic formula for that going to be? Well, it's clearly going to be, formula starts with equals. It is going to be the emissions divided by the population per capita per person. Now you'll see when I do that, because these numbers are in millions of metric tons, I've got a ridiculously small number happening. So actually, I'm going to take this rate, because it's a rate we're calculating, and multiply it by 1 million. And that because the original figures are in millions of metric tons. 1 million, by the way, can be written more easily as 10 raised to the power, that little caret or hat symbol, and 10 raised to the power of 6 will give us a number that's a bit easier for normal humans to understand. So if I hit return on that, we get a number now that's in tons not in millions of metric tons, and it's per person, not the total emitted by the country. Now you'll see it's given me an option to autofill down the column. So I'm going to take that, and we've got all of those numbers. But there's going to be a problem. Look what's happened here. For some countries, we don't actually have numbers for CO2 emissions. Yet it's run the calculation and given us zero. As I'll discuss in the next session, zero and null or missing data are not the same thing. So if I just took that and then I want to do calculations from it, I've got zeros where I should have missing data that wouldn't affect the calculations. So this is a common thing you need to watch for in spreadsheets. So I'm going to do this again and do it in a way to show you how to avoid turning nulls into zeros if you're doing a calculation like this. So I'm just going to delete that column again and recreate it again, just so we definitely have it nice and clean, and call it CO2 emissions cap. Okay, that's all good. Now I'm going to paste this formula in, because if I try and type it, I'll probably get it wrong. Okay, and then I'm going to explain it to you. Oops, what's it doing there? Oh, I see what the error is. I didn't paste the closing parenthesis. Okay, so what is this formula? And you see a formula I type or place in there also appears up here. Now this bit over to the right is the same calculation I just did. It's the emissions divided by the population multiplied by a million to give me the emissions per person in tons rather than millions of tons. But the whole thing is wrapped inside an if function. So it's a conditional calculation. And what this is saying is if the cell I2 for carbon dioxide emissions is blank, then, so, comma, then don't put anything there, leave it blank. And if it's not blank, run the calculation. So a little bit more complicated, but this will give us what we actually want. So if I now autofill that all the way down, we should see that when we get to the countries that have the missing data, we haven't calculated a value. We've got a null, which is what we want. By the way, don't worry too much about what's going on here. This is numbers in scientific notation, which sometimes happens and are a bit annoying. Let me just fix that by formatting the numbers to like that, and then they're so small is why they were going that way. Okay, so I've now calculated a rate per person of carbon dioxide emissions, and it's now in tons rather than in millions of metric tons, because that doesn't make sense at the level of a person. Okay, now what if I want to look, and this is the question, this is the interviewing data, I'm formulating a question. I want to know how the emissions, well, firstly, the total emissions, so go back to those original numbers, have changed by region and by year across this time period. Now, this is where something called, what I'm going to be doing now is grouping and summarizing. And I'm first going to do it not on the rate. I've already given you a big warning about doing this type of calculation on rate. So I'm going to do it on the total numbers, the total emissions, but for each country. So let me show you how now to do a pivot table, which is how you can group and summarize data in a spreadsheet. So I'm going to insert a pivot table. Always put it in a new sheet. Notice I selected all of the data before I did that. So create, and we get pivot table 1, and we can now start to populate it with data, grouping, and summarizing. And the way you do that is to put the variables you want to group by into rows and or columns. So I'm going to start by against rows, selecting add, and it's selected status, and I don't want that. I want to add the year. So you'll see what's happened now. We have all the years in our rows. Now, if I just wanted to go straight to, well, what was the global total of emissions by year? I can forget about columns and add values, and it will be CO2 emissions, not the per capita one we just calculated. I want the total emissions for the whole world. Okay. And if I add that, it will do a summary. Now, the default here, it's chosen sum, add all the numbers up. And that's what we want. We want to add them up in this case. But sometimes you might want a different calculation. You might want the average, the median, the maximum, the minimum. Count A is a count of, I think, the unique values in a data set and so on. All right. All right, so that has given us the global emissions in millions of tons of carbon dioxide equivalent by year. But what if I want region as well? Well, I can go to columns and add, and it's put in something else that I don't want. Go away. Add, whoops, sorry, it is jumping to conclusions. What I actually want here is region, which is there in the data. So now we can see those numbers, the grand total over the right are the global figures. We had those previously when we just grouped by year, but now we have that broken down by region as well. Now, if I want to take a quick look at that, let's select the data I will need. So that is all of the data on the total emissions. Notice I haven't selected the grand totals because I don't want them in the chart I'm going to make. I haven't selected year yet. I'll come and do that in a minute because that will be the x-axis and I can select that separately. So I'm going to, again, insert a chart with that data selected. Now, this time it hasn't given me the chart I want. I want a line chart for this. I don't want column charts for each year. That isn't really helping me understand what's going on. So if I select a line chart, however, now this is making a bit more sense. We can understand what's going on. And we see that the big driver of the global growth in carbon dioxide or greenhouse gas emissions in carbon dioxide equivalent over this period has been growth in East Asia, the East Asia and Pacific region. And that, if we went and drilled down into the data, would largely be due to China. There's also some growth in South Asia, largely due to India. That little dip there is the pandemic, by the way. We don't have the years on the x-axis, but notice you get an option to add the x-axis, and then you can select a data range. And then if I just highlight the data I want to use there, now we've got the years on our chart as well, and we've got a pretty informative view of how total greenhouse gas emissions have changed across this period by region, whereas the original data was by country. Okay, so always name everything. I'm going to rename this as, what is it? CO2 emissions region year. Tells me what that is all about. Okay. Now I'm going to do something a bit more complicated. And what we're going to do now is calculate the CO2 emissions per capita per person by region and year. But remember the warning slide I gave you about making calculations from rates. We don't want to do this from column J that I made. We want to do it from these two columns. But we can do that in a pivot table in one step. So let me show you how to do a little bit more of a sophisticated pivot table when you're recalculating rates at a new level of grouping, which is something you might need to do. Okay, so I'm going to select all the data again. I'm going to go to Insert, and I'm going to insert a pivot table again in a new sheet. Okay, so my rows and columns are going to be set up the same way. So for rows, I want year, and for columns, I want region. Okay, so that's the basic shape of the pivot table. But when I come and do the values that I'm going to fill that table in with, I am not going to select any one variable in here. And particularly, I am not going to go to CO2 emissions per capita, even though that's what I'm trying to calculate. I'm instead going to use a calculated field. Now, by default, the formula is just equals 0, which is why it gets filled with zeros. So let's think about what we actually need to do here. So I'm going to summarize using a custom formula. Okay. Now I'm going to, again, copy the formula from my notes, and then I can explain to you what it does. But if you were doing this live, you would, and you'll see it's taken that formula and it's made those calculations for me. So what is the formula? Well, let me roll over. It is the sum of the CO2 emissions divided by the sum of the population. Remember that from the slide. And then because when I do that, it makes sense to get into tons rather than millions of metric tons, I multiply by 1,000,000 or 10 raised to the power of 6. So that's an example of how correctly to calculate a rate at a different level of grouping if you have the numerator and the denominator. Do not go straight from the rates themselves in the data. Now I'm going to do a bit of formatting here. I'm just going to reduce the number of decimal places so it is easier to understand, easier to read, and doesn't have sort of spurious precision. And then I'm going to make a chart of that again, and we can see that this will look rather different. Okay, in terms of like who's responsible for current global warming. So if I select that data, ignoring the grand totals, ignoring the years for now, because I'm going to add that range in later, and insert a chart and do it as a line chart. Something weird is happening here, but I think I can fix that. What has gone on there? Well, don't worry too much. I think it's just putting some years out of order. Is possibly what's happened there. Let's, oh, I see what's happened. It's tried to select East Asia and Pacific as the x-axis. So let's remove that. Yeah. And add the x-axis, select a data range. And again, we want the years to be the x-axis. And this gives us a rather different picture of kind of what has been going on. the whereas I'm trying to see where, oh, sorry, we still have that being down there. So for some reason, I've managed to lose East Asia and Pacific off this chart. But rather than try and put it back on, we can see that North America has this very high GDP per capita. And if the line for East Asia and Pacific had correctly come under the chart, always when they do things live, weird glitches happen. But that would be down here. It would be growing, but it would be down here on the chart. So that pivot table looks pretty different from the other one. Again, if I were going to come back to this later, that would name this so CO2 emissions per cap region year. But hopefully that illustrates for you the general principles of making pivot tables, being very, very careful with rates and calculating them at different levels of grouping to go from the original numerator and denominator for the rate. Don't try and calculate from the rate at a different level of grouping. Okay. So I'm going to finish with this spreadsheet. There's plenty more you can do to practice with the other variables in there, bearing in mind percent land forest, percent land arable. Those are rates. The denominator, if you for that, is going to be land area. So you can calculate the actual area of land forest from the for arable land or forest land in a calculation from the rate and the land area. You'd have to think about how to do that, but that is the sort of logic you'll need to get your head around. And then you can go about calculating percent land forest by region over time in a similar way. So you can practice these concepts. Okay. Last thing I want to show you are some slightly different calculations. And I'm going to show you how to calculate rolling averages and cumulative totals, which is, again, a similar sort of thing that you, a thing that is a fairly common task in data journalism. And I'm going to use COVID data. It's not environmental data, but it is absolutely ideal for this purpose. And it also allows me to demonstrate something else, which is importing data from a CSV or other text file, which is on the web. Now, for various previous trainings, I made this data which shows the number of new cases and new deaths reported worldwide according to Our World in Data, which is a good data portal, from the beginning of the pandemic to sometime in April 23, I think it was. Yeah, we go through to April 23. And it's at this URL, which I'm going to copy. That's also in the notes for the class. So I'm going to go back into my Google Drive in the folder I've set up for this, and I'm going to make another Google spreadsheet. And then I'm going to use a function which is called import data. By the way, the notes for this session give you a reference to, import data. Shows I can't walk and chew gum at the same time. Talk and type at the same time. Okay. And then if I put that URL within quote marks and hit return, it should think about it for a little bit. It'll throw me a warning saying that it wants to receive data from external parties. Yes, I do. And then it should import the data. Now, this also illustrates another common thing with spreadsheets that can happen, that if you're not aware of it, copy and pasting, I saw a question there, isn't necessarily a mistake. No, as long as you're sure you've copied and pasted the whole thing. and that the separators are going to be recognized. So if you got tabs, it might work. Commas, it might not. I would always do an import, either import like that, or here I'm importing directly from the web. So not necessarily a mistake, but I don't generally do it. Okay. You probably noticed already what on earth is going on with these dates. In the original data, they were dates in a standard, international standard format, which is the 4-digit year, the 2-digit month, and the 2-digit day. But now they've become these weird numbers. Now, some of you, if you have experience with spreadsheets, you might have seen this before. Spreadsheets store dates as numbers, and it's, I think, from something like, is it the 1st of January 1900? It's something like that. I can't remember what it is, but it's the number of days that have elapsed since whatever its reference is. So if you see dates coming through like that, don't panic. Go to your format menu, and I've already got set up. You may need to go to custom dated time, but I've already got set up because I use it a lot, the international format for dates. And if I just reformat from the format menu a number, I'll be able to fix stuff like that relatively easy. So let's do some naming. So this is COVID cases and deaths. And this is the, I'll maybe just call, well, we're only going to do one sheet, but I'll just call it world because that's what we're showing. Okay. All right. So we have cases, new cases and new deaths, the number of each reported each day across the world. So let's think about what we might want to calculate here. Now, remember that there's a weekly pattern, and quickly I can show you that by inserting a chart here. You see up and down, up and down, up and down, up and down every week. Now, if we want to get a view the trend more clearly, we want to smooth that weekly pattern, which is an artifact of reporting. It's not the real underlying trends. Because it's a weekly pattern, we can do it with a 7-day rolling average. So I'm going to create a new column and just call it 7-day average cases, something like that. Okay. Now we've only got 7 datas, if 7 values. If we go down to row 8, and that will give us 8 minus the header row is the first 7 values. So if I pop into that cell, what I popped in was average C2 to C8. Remember, the colons are range. So that has calculated the average of those numbers. Now, if I just, it's not giving me an autofill option, but if I go to the bottom right-hand corner and double click, those numbers should fill out down throughout. And I'm going to get rid of the decimal places on them, and also quickly show you the effect by inserting the chart again. And you'll see how that smoothed it out. So we now have a 7-day rolling average. And the reason this works is because if you watch the formula bar up here, spreadsheets by default, as you copy them down, which is what I did when I clicked the bottom right-hand corner of that cell, it now goes C2 to C8, C3 to C9, C4 to C10. So it's using the same 7 rows window, but the window used changes by 1 as we go down the thing. So that calculates exactly what we want. Now, similarly, if I just copy that whole column into here, um, look at what's going on now. Rather than it being C2 to C8, it's D2 to D8 because we move one over to the right. So it moves one column to the right by default. And we've now got not the 7-day average of cases, we've got the 7-day average of deaths. So this is a nice thing about spreadsheets. You can kind of copy formulas around and they will move around the spreadsheet with you, which can, in this case, be exactly what you want. Okay, so I've got the 7-day average of cases, 7-day average of deaths. If I want to create charts that and just look at the data that smooth out that weekly noise. So rolling averages in general can be pretty useful for kind of smoothing out the noise in data and looking at the underlying trend, and that's how you can calculate them. But what if I want to do the cumulative? What I want to know is how the number of cases or the number of deaths has grown over time, which is a different calculation. So I'm going to call this cumulative cases. Now, on one level, it's going to be the sum of the cell you're in and all the ones that went before. So how do we do that? Well, the way we do that is here. If I want cumulative cases, I'm in column C. So my function is going to be sum because I am adding things up. But I'm going to go C $2 to C2. And it's going to suggest I autofill it, which I'm going to accept. Now let's have a think and a look at what has happened there. Look at the formula bar to see how it changes. So in the first one, the cumulative cases is C2 to C2. It's the sum of one value, which is 0. So it's 0. Second column down, it's C $2 to C3, C $2 to C4. What the anchor has done, and the dollar is an anchor, is meant that I always refer back to row 2 for the beginning of my range. If I hadn't done that, it will go C2 to C2, C3 to C3, C4 to C4, because that is the default incremental behavior of a spreadsheet. Anchoring to C2, anchoring to row 2 by putting a $sign in front of it means that I always calculate the range starting with the. Now, why didn't I put an anchor in front of the C as well? That would anchor it so it always calculates from cell C2. Well, the reason I didn't is because I wanted to be able to do this, which is copy it over and now have it be D $2 to D2 and so on. So it'll do the same calculations, not for cumulative cases, but for cumulative deaths. So the general point here that I want you to take home is that for certain calculations, anchoring to either a row or a column may be important. And you may need to anchor to a row and a column so that as you move through a spreadsheet, it's always calculated with reference to the same cell. But you may need to anchor to rows. You may, like I did here, you may need to anchor to columns, but know that you can anchor to a row or a column by putting $1 in front of the number in the case of a row or the letter in the case of a column. And if you want to anchor a calculation to a particular cell, put $1 in front of both of them. So that's what I have with you for today. Next, please do go away, look at the video, which should be posted soon, and try and practice this stuff. I'm happy to stay online for some time and answer any questions you may have. And next week, we're going to come back and I'm going to talk about acquiring data, cleaning data, knowing when you need to clean data, and also extracting data from documents. We're going to work with Google Pinpoint for the latter, and for cleaning and processing data, so we're going to work with OpenRefine. OpenRefine is a tool you will need to download. Google Pinpoint you'll need to sign up for. So I'm going to stop sharing at that point, and open to I've got many examples of investigations I've done that are data-based. What I would warn you is that a lot of the stuff I do, I sort of do introductory classes that are sort of spreadsheet based. Like most professional data journalists, when I actually do my own work, I'm writing code. I work in the programming language R primarily. Most data journalists work in R or Python, and for certain things, you'll need you'll need somebody who can do that. But I can certainly give you some examples of data stories of varying degrees of complexity, and it's probably easier if I put those into the WhatsApp with a few notes explaining what they are, I think, rather than trying to come up with them off the top of my head here. Anybody have any specific questions about the stuff I was talking about today? Was anything confusing, unclear, anything I went through too quickly? Do feel free to chip in and challenge me on anything. Okay. Well, we're nearly at time, aren't we, Fola? Is our allocated time at the at half past the hour?
Um, I might, sorry, I have a question. I'm Mustafa Dabo, Gambia, the
Hello,
Gambia. Hi, how are you?
I'm
So,
good.
I mean, cool, I'm okay. So I have actually data that I'm planning to use in a story, and this is a number of payments that were made to different businesses owned by different individuals. So that I couldn't put into the kind of chart that you have shown, because I wanted the payments to show, the amounts to show, the individual company names to show. And so that how do I, what kind of a platform would you recommend I use to uh,
Well, I'll have some questions, but to flag that I'll be doing two sessions later in this series,
okay,
specifically on visualizing data, so storytelling with data.
okay,
Um, the tool I use most commonly is Data Wrapper. It has a range of different chart types. I think the important thing I would want to think about is like how many companies have you got in this data? That will be the first question I have. I mean, the kind of obvious way to show that, if you're just showing the magnitude of the payments, I would most likely do a vertical bar chart. Most likely, that then allows you to put the company names down the left-hand vertical axis, right? Otherwise, which is much better than having it flipped around, and which means that all the names will be at 90 degrees. Much easier to read like that. Um, and I would order them. I would sort them from largest to smallest. Now, if you've got many companies, you don't want if you've got hundreds, you don't want a massive column chart a bar chart that kind of goes scrolling off your screen. But a nice thing that Data Wrapper has is the ability to create paginated tables, and those tables can include bar charts. So if you had, say, 200 companies with payments, I would use the Data Wrapper paginated table and it can be made searchable as well. So people can, if they want to search for a company, they can start typing a name in, and the table will filter down to show that. But by default, you can set it to show maybe 10 or 20 of the largest payments first, and then you can flip through to see the smaller ones on a separate page for each one. It's a really useful chart type. Of course, it depends if you're working online or in print. I'm talking about working online here. Uh, in
Yeah, I
print,
work online.
yeah. So my recommendation to you for that would probably be a sorted and paginated data wrapper table using the bar chart option that's available to you within a table in data wrapper. But we'll talk more about data wrapper in, I think it's July.
Are you going to have a session on data using a data wrapper?
I am, yes.
Okay, good. Good.
But that's
So,
towards the end of the series, right? So it's not for a few months. Viola will have the dates to hand. I don't have them immediately to hand.
okay. All right. That's all good. But in the meantime, is it available on the Google Sheet where you have access to Google Sheets? Or this is a new platform on its own? I have to Google maybe data.
There is a so like I might make charts in Google Sheets for my own purposes, really, to see what the data shows me, or if I've made a pivot table to see what that shows. Or to look at a distribution. If I'm presenting anything for publication, I'm not using Google Sheets, right? I'm using other tools, of which Data Wrapper would be the one I most commonly use.
All right. Beautiful.
And we'll come to that in a subsequent session.
Okay.
I think Emmanuel has a question in the chat. Emmanuel, you're
Do I
muted.
do I have recurrent questions I ask of data? Well, um, it's often what is the largest, what is the smallest, what are the outliers, what are the unusual. That's another reason to look at distributions, actually, is sometimes the story is in the numbers that are just so weird and so different from anything else. Why are they so weird and different from anything else? It's often filtering down to a category that I know is particularly relevant. I did a story for BuzzFeed News some years back that was looking at animal experimentation, and it was data. Um, it was the numbers of animals used at different labs in different years in a particular type of experiment. And I filtered down to what they call column E experiments. They're really nasty. There's pain and suffering, and there's no alleviation of that. And they have to be justified. And I knew I wanted to do something looking at the sort of cutting edge of the ethics of animal experimentation. So I went from this database of run by the USDA that collects data on animals used by labs under the Animal Care Act. And I filtered down to research on primates only and these column E experiments. So it was really a filter. And then it was a group and summarized by year. And then I saw that these had increased massively since, since the early 2000s. And then I went to look, well, okay, well, what are these experiments? And it was all to do with basically research on biodefense. So, they were doing stuff like, giving animals pneumonic plague or radiation, and they were trying to develop therapies, but it involved enormous amounts of suffering for, animals that you'd think we were trying to use less, primates, monkeys, essentially. So there it was a filter and a group and a summarize, but it's really where is the story going to be in this data? I start with the questions that I have of a particular data set. So with that one, it's what is going to be the nastiest stuff that people are going to care about and what's happening with it. And I was kind of shocked to see it was increasing. I did not expect to see that. When I did, I knew there was a story there. Often it's, I've been doing a lot around the Trump administration and its effects. And one story I just did for Inside Climate News is looking at how the federal workforce we looked particularly at the Environmental Protection Agency, and we looked at from this massive data set that the US government's now releasing on snapshots of the federal workforce each month. We looked at how many people were working for EPA end of January 25, beginning of the Trump administration, to the end of January 26. So it's the first year of the Trump administration, give or take 10 days. And then I grouped and summarized that in different ways. So I didn't just look at the total numbers. I looked at, okay, what particular categories of employees have been lost. And that allowed us to see, so grouping and summarizing in different ways, that disproportionately it was people with more scientific qualifications, people with doctorate degrees. Disproportionately, it was team leaders. The staff was going down a lot, about more than, was it 24% overall, I think, something like that. But I did a lot of grouping and summarizing to figure out, well, what in particular has been lost, which allowed us to do a much more powerful story about, EPA's lost a lot of staff, but it's particularly losing people in leadership roles, people who are scientifically qualified, people who work in the areas of environmental health. And then reporting out beyond that, my colleague who did most of the on the phone reporting about it was able to use the questions I'd asked of the data to get to a much fuller story of what on earth is going on at the Environmental Protection Agency under Trump. I can share that one with you because it's quite a nice example. Like I wouldn't have wanted to be doing that in a spreadsheet because the original data is more than 2 million rows long for each month. So, that's where the fact that I work in other ways comes in quite a lot. And I could also do the entire federal government, every single agency, by running a whole bunch of code I'd written. But the principles are the same, right? It's filter, group, summarize. So a lot of the trick of getting into thinking like a data journalist is thinking, you're not really starting with the data. It's thinking with what do I want to know? And then what is the data, what is its structure, and then how can I apply these methods I showed you, and in particular, how do I filter, sort, group, and summarize to get to the answers to the questions that I'm trying to find out. And just so much of what I do, it may be with huge data sets, it may be I need to do a massive amount of writing code to automate stuff, but it's the same principles I showed you today. So the questions should be the easy part for you as reporters. The less familiar thing may be turning the questions into a series of operations that you can do on data. But that comes with practice.
Yeah, I'm gonna have to move all questions to the WhatsApp group. Peter is on WhatsApp, so you can ask your questions there. We are about 9 minutes over time, and I know a lot of people have already dropped off. So thank you, Peter. If there's any last thing you just want to drop before we move on, please
No, I'll
let me
just
know.
say
You can do that now.
do try and practice this stuff. The sources of data, I have some information from that in the notes for next week. So take a look at that. I have, I think, some suggestions for data sets. If not, I can add some. But yeah, do practice this stuff. It you know, working well with data, it's about being organized, understanding what you're doing, understanding the structure of data, understanding how to turn the questions you have into a series of operations with data, practicing it and checking all the time.
Yeah. Thank you so much, Peter. Thank you, everyone, for staying to the end of the class. Please put some of your questions to Peter on WhatsApp, and Peter would have 1 or 2 hours within the week to answer them. And like we always do, the video of this particular session will be uploaded, and the link will be shared with everyone. If you need access to, I think everyone has access. It's a public link to the material that is on GitHub. The link is available on WhatsApp. If you want me to drop the link again, I'll do that happily. And check your emails for further updates if we have any.
Okay, bye everybody.
Yeah.
Hope that was somewhat useful for you.
Bye, everyone.